Imagine an aircraft worth nearly $100 million simply vanishing from the world. No commercial flights, no records, no trace on the radar. For years it remained an absolute mystery, exported, received, and then erased from the map. What for anyone else would have been an international news case and a matter for litigation, instead turned into a puzzle that would take decades to reveal its pieces. In the early 2000s, one of the first Airbus A320s sold to China disappeared from the usual logistics chain. French manufacturers and technicians watched in disbelief as that aircraft, a finely calibrated work of engineering, failed to appear on any flight lists or passenger registries. The authorities, with a somber tone, labeled it a ghost plane. What had really happened to such an expensive and complex machine? Decades later, former officials and reports linked to French intelligence unearthed a version that sounds straight out of an industrial espionage script. According to testimonies and technical analyses, the A320 had been systematically disassembled. It wasn't a routine inspection. The operation aimed at something far more ambitious: to understand, in depth and detail, every piece, every joint, every circuit in order to reproduce them. The result of that learning would be a homegrown aircraft, the Comac C919, China's bet to compete with Boeing and Airbus in the narrow-body segment. But this story has several layers worth separating. On one hand, there's the engineering. Copying a modern aircraft is not just about replicating shapes. It involves mastering material chains, manufacturing processes, certifications, avionics systems, and a network of international suppliers. On the other hand, there are the diplomatic and commercial tensions. Publicly accusing a country of technological theft could burn billion-dollar contracts and close essential commercial doors. According to those with experience in the sector, that weighed as heavily as any technical evidence. A former Airbus intelligence executive shared disturbing details. There were structural similarities between the C919 and the A320 that, in his view, exceeded what could be expected from simple design convergence. Other experts nuanced this view. Technological influence and learning through analysis of an existing model can explain similarities in certain technical solutions without implying a literal piece-by-piece copy. The technical truth is usually a mix of inspiration, original engineering, and in some cases, more direct access to know-how. In 2021, nearly 20 years later, that missing plane was found abandoned in a provincial field. It didn't return with its registration intact. Rather, it resurfaced as belated evidence of a story where engineering, politics, and commerce intertwine. For companies like Airbus, and for governments, this raised a key dilemma: confront publicly and risk billion-dollar contracts and trade retaliation, or maneuver cautiously and prioritize the continuity of critical economic relations. Meanwhile, China pushed forward with its own initiative. The C919 was presented as the first major step in Chinese civil aviation in decades, a domestic design that aimed to reduce dependence on Western manufacturers. The strategic objective was clear: secure the vast domestic market first and eventually compete on international routes. But there's another fundamental truth. Mastering aircraft manufacturing requires more than replicating forms. It demands international certification, maintenance reliability, spare part networks, and the trust of airlines that invest hundreds of millions in each unit. Here, a revealing paradox emerges. Despite the ambition and industrial effort, the C919 has not, at least according to public data and foreign purchases, managed to attract international operators on a large scale. While the Boeing 737 MAX 8 series and the Airbus A320neo dominate the global market, amassing the vast majority of sales and flight hours on domestic and international routes, the Chinese model faces challenges that go far beyond engineering: confidence in the supply chain, certifications recognized by external regulators, and above all, the perception airlines have regarding safety and post-sale support. This is not just a story of technical competitiveness. It's a study of how the global aviation industry is organized. For decades, Airbus and Boeing have maintained near duopoly control. More than 80–90% of the single-aisle commercial aircraft market has been in their hands. That position isn't unbreakable, but it is reinforced by supplier networks, service agreements, long-term contracts, and certification standards that don't change overnight. When one of the pillars of that system, through quality errors or safety failures, falters, the market experiences shockwaves. Boeing's recent issues, quality control failures, production halts, and regulatory controversies have shown just how fragile a seemingly solid chain can be. Airbus tried to ramp up capacity, but aircraft production is a slow machine. You can't multiply planes as quickly as you can light up a headline. In that context, the idea that Beijing sought its own solution, a national aircraft capable of meeting internal demand and later conquering foreign markets, makes strategic sense. However, international adoption depends on factors far beyond design: trust, support, alliances with airlines and regulators, and the ability to provide parts and maintenance worldwide, on time and at scale. Returning to the ghost plane, more than an isolated episode, its story exposes the thin lines between industrial espionage, indirect technology transfer, and aggressive commercial practices. It also reveals the tension between defending intellectual property and sustaining economic relationships that generate jobs and contracts worth tens of billions. And if this leaves you wondering who truly wins or loses in this game, consider this: aviation isn't just steel and software. It's a global network of trust built over decades of compliance, safety, and yes, patience. Think about that for a moment. Today, both Airbus and Boeing face a storm threatening to paralyze the commercial skies: historic production delays, supply chain bottlenecks, and an ever-growing demand. Airlines across the planet are desperate to expand their fleets, but the giants of the air simply cannot keep up. If an airline were to place an order today for a new 737 MAX or an A320 Neo, it would have to wait more than a decade to receive it. 10 years. An unthinkable span in an industry where time literally equals money. And the most alarming thing is that these waiting times show no sign of improving. Each day, delays pile up, shortages of engines, electronic components, and specialized labor worsen. And manufacturers struggle to regain a balance that seems ever more distant. At first glance, this could seem like the perfect opportunity for a competitor like Comac's C919 to conquer the global market. On paper, its numbers look promising: over 850 registered orders and 24 confirmed customers. For a company just taking its first steps in international commercial aviation, that sounds impressive. However, numbers can be deceiving. A closer look at those contracts reveals a troubling pattern. 23 of those 24 buyers are Chinese airlines or leasing companies, and many of them, directly or indirectly, are under the control of the Chinese state itself. In fact, the same government that funds Comac also owns most of the national airlines. In other words, the vast majority of those orders come from the same state-run business circle, raising questions about how independent or genuine that demand really is. This leads to an inevitable question. If the world is suffering such a severe shortage of new aircraft, why hasn't any international airline yet taken a bet on the C919? In theory, regional carriers in Asia, Africa, or Latin America, which often seek more affordable alternatives, should be interested. But they're not. And that's due to three enormous obstacles that expose the project's deepest weaknesses. The first challenge is performance. Although the C919 was conceived as a 21st century aircraft with modern aerodynamic design and advanced materials, its performance falls short of its Western rivals. It has shorter range, lower fuel efficiency, and an operational record still too limited to inspire confidence. This surprises many, Because in theory, a new model should outperform platforms that have been evolving for decades, like the 737 or the A320, but the reality is more complex. The issue lies not so much with Chinese engineers, but with COMAC's technological dependence on foreign suppliers. And here's a fact that changes everything. Around 90% of the C919's components are manufactured outside of China. Electrical systems, avionics, landing gear, flight controls, most come from US and European companies. Although China is known as the factory of the world, it still lacks the experience and precision required to internally develop the most critical components of commercial aviation. That dependence creates a paradox. Western suppliers do collaborate, yes, but with extreme caution. Concerns about technology misuse, reverse engineering, and geopolitical tensions mean many of these companies refuse to share their most cutting-edge developments. As a result, the C919 integrates solid, proven technology, but from earlier generations. Functional, yes. Cutting-edge, no. Safe, perhaps, but not revolutionary. This is most evident in its engine, the LEAP-1C. At first glance, it seems like a marvel of engineering, belonging to the same family of turbofan engines that power the A320neo, LEAP-1A, and the 737 MAX, LEAP-1B. However, there's a crucial difference. While the Western versions achieve up to 15% better fuel efficiency compared to their predecessors, the model installed on the C919 lacks some of the latest optimizations and advanced composite material improvements. In short, the Chinese aircraft lags a step behind in the race for efficiency, and in modern aviation, that small step translates into millions of dollars per year in operating costs. Every liter of fuel counts. Every extra kilogram penalizes. Every aerodynamic or technological improvement can mean the difference between commercial success and silent failure. Thus, while Airbus and Boeing face their own production crises, the C919 faces another, the crisis of trust. And in an industry where reputation and reliability are as valuable as steel and titanium, that might just be its greatest challenge.